I watched John High's video in which he builds this really cool bar clamp out of wood and steel, and this inspired me to make my own bar clamp, which is this one. This one is entirely made out of steel, except for the handle, of course. Now, I'm not a very good welder, so I took this as an opportunity to practice, and my plan is to make a bunch more of these in different sizes. But in this video I'm gonna show you how I made this one. So I got myself some mild steel from the local metal dealer, and here's my drawing. The first thing I did was to cut all the steel parts to size. I used a chop saw, but you could also use a circular saw, a grinder, a hacksaw or a plasma cutter. This is how the jaws will be assembled. So that the bar fits in there like this. For aesthetic reasons, the fixed jaw is tapered. I marked the taper and then cut the pieces using the grinder and a thin cut-off disc. I chamfered the edges for welding the pieces together. And I welded up the first two pieces. And I'm cleaning the welds using a wire brush wheel. And chamfering more edges. And this is welding up the fixed jaw. I think I should have made these chamfers bigger so that the welds would have more space. And I really shouldn't have welded here, because it doesn't make it stronger and looks like crap. This is how the moving jaw goes together. You can see that if the tip of the jaw is pushed upwards, the bar can slide freely through the jaw. But when it's pushed down, the geometry of the parts will lock the bar in place. I tacked the pieces together to see if it would actually work. And it seems to work really well. Before I tacked the last part in place, I placed some pop can shim in there so that the bar will still fit through the hole. And after everything had been welded together, I could try it once more. For the pad I cut a piece of 30mm round stock and marked the center using my squares. I drilled a hole partially through and then shaped one end of the threaded rod using the drill press grinder method. The pad can now turn and swivel freely on the lead screw. I cut through one side of a washer and bent it open so I could fit it around the neck of the lead screw. I put some grease in the hole and then tacked the washer in place. After making the grip scales out of a piece of spruce, I glued them around the lead screw. Later I added a crosspin, which I didn't film. Because the handle was too large, I planed off quite a bit of material. And I added a pad to the fixed jaw and spray painted it black to give it a bit of protection. And here it is all finished. So I was curious to see how much force that clamp would be able to apply. I rigged up the bathroom scale test using a 5:1 mechanical advantage. So let's see. And it becomes a bit more harder to turn. That piece of wood is bending considerably and making funny noises. And the scale has bottomed out at about 6,000 newtons of force. I think it would be able to go a little higher, but I'll leave it at that. Just for comparison, one of my now second biggest bar clamps. Now we are about at 3,500 newtons of force. And it feels like the casting would snap or deform if I cranked it up a little more. But I think this wasn't a fair comparison. Thanks for watching.